problems, so
Okay.
I'm going to try and send it to your email.
Let me give you, this is the best email to send it to. I'm writing it on my screen right now. And this is a little different than the main email on my digital math tutor website, which gets forwarded to me, but it doesn't come direct, so it sometimes takes a little longer. But this one is the most direct one.
Okay, great.
Yeah, always use this one. And again, send it as a large file attachment if you're using an iPhone.
Okay, how would I do that?
Unfortunately, I do not have an iPhone. So the way I do it's different than the way iPhones do it. I'm not sure. Have you ever taken a picture with your camera and sent it to an email?
Yeah, I'm pretty sure I've
Well,
sent
go
stuff
ahead
to.
and try it the way you think you know how to do it. Um, the one thing that's key is that it not come as the body of the text of the email,
Oh, yeah.
but specifically as an attachment, which allows me to manipulate it and bring it up on the screen a little easier. Sometimes
Okay.
I can see it if you send it as the body. It just kind of depends on the email. Let me know when you've sent it.
Okay, I sent them.
Okay. Um, okay, I was just looking at the previous email, canceling on the 28th, I think.
The No, my mom and I were scheduling appointments, and we accidentally scheduled one for Monday, December 26th,
I
and we were.
noticed that. I saw that. And that was the
Yeah,
very first one I saw. That was a little peculiar, I thought.
yeah. No, we were trying to schedule one for tomorrow,
Okay.
Monday the 28th.
You know, I wondered if that wasn't what was happening, is that when I saw December 26th on there, I asked myself, I wonder if they were trying to schedule for tomorrow. Um, let's see. So you've sent it?
I have.
Ah, you know what? It appears, yeah, it did. It came through in my spam, which never happens. That's okay. I can get to it. Are there two of
Oh,
them?
yes, there are. It's a front and back side of a worksheet.
All right. I think I can get to it. Yeah. This is the front, I gather.
Yes,
All right.
and please ignore the stuff from problem 2 down, because that is completely wrong. I
So
was doing it.
where are we starting here? Are we starting with one?
Uh, no, I think I have one.
Okay. Where do you want to start?
Number 2.
Okay. And number two, does it have to do with number one also?
It does, yeah.
I'm going to have to
The whole.
read, let me read number one.
Okay.
Okay. So number two basically asks or answers number one. All right. I'm kind of getting that static again.
Yeah,
You hear it
got a little.
I'm going to have to move back here. So write the function rules for each, where x is the number of texts and f of x is the total monthly cost. All right. So x equals the number of texts and f of x cost. All right, so with no plan at all, what is the function? In other words, we're going to have, it looks like, a different function depending on the plan that we use, correct?
Correct.
That's what A through D is. So no plan at all looks like you have it correct. It's 15 cents per text. So what you wrote there is correct.
Okay.
Okay. With the 400 text plan, you pay $4.99 a month for 400 texts, and anything over 400 is 15 cents per text. So let's think about that. We're going to pay $4.99 plus what?
Plus 0.15x, or
No, because we get 400 texts for that.
oh, so 400.
Well, it would be x minus 400. In other words, if x were 400, this would be 0, and we would just pay $4.99, right?
Right. Okay.
That's the way you always want to look at these problems, is after you come up with what you think is the correct answer, then test it in a couple of scenarios. What if x were 401? This would be perfect. We'd pay the $4.99, plus we would have one text that we would be charged for at 15 cents per text.
Okay.
Okay, so this should be A. Now B. Well, excuse me, that was B. C is the 1,000 text plan. So what do you think that should be? We'll call that G of X, just to differentiate.
9.99 plus x minus 1,000 times 0.15.
Yeah, I'm in a habit of leaving that initial 0 off.
Okay.
Only because it serves no purpose. I've never been able to see the purpose of it. All my students tend to put it in there because that's what you've been taught in class. But notice that it does not serve any purpose at all. In other words, there is no difference between this number and this number. It's just a waste of space and a waste of a 0, in fact. And you could end up mistaking that if, I don't know, there's all kinds of bad things that could happen with that 0, and I don't see any good at all. So you can do it however you want, but my thinking is I never put it in if it's not needed. And this also works if you send exactly 1,000 texts. You won't have any additional ones, and you'll pay $9.99. And And finally, unlimited. So what is h of x? What is the answer? I can't quite read your answer on your paper there.
Yeah, I apologize. I put 14.99x.
Okay, think about that for a moment. Is that going to be the case?
I think so.
Well, what if you sent 10 texts?
Oh, no, no. Okay.
You'd pay $149.
Right. That's okay. So would it be 14.99 plus 0.15x?
Well, you get unlimited messages. So even if x were 1,000,000, I would only pay $14.99. So there's no x for part D. It's just 14.99.
Okay.
See why? In other words, x is not part of the equation. It's kind of like a horizontal line. And in fact, if we were to graph these three functions as one, in other words, if we want to call them all f of x and make it a piecewise function, then the final part of that graph would be a horizontal line. The cost is $14.99 if you choose that plan, no matter how many texts you send out. That's why I asked, because this looks a lot like $14.99, but then I saw that little X afterward.
Yeah.
All right. Let's look at number 3. And, you know, let me just make a comment here. We could call all of these f of x if we chose to, and if we put these limiting factors like you have here. In other words, if we want to answer this with a piecewise function, then it's all f of x. Okay?
Right.
And the first part is x greater than 0 and less than 400. Well, that's going to be f of x equals 0.15 times x. Well, not really, because it depends on which plan you choose.
Right.
So to me, it's not really a piecewise function. It's only a piecewise function if you're going to let the plan optimize itself, and that's not the way that's not the way it works. The phone company asks you to pick a plan. So we can't really call it one function, and if x is between 0 and 400, we'd pay one thing, and if x is between 400 and 1,000, we'd pay another. If that's the way it was structured, then we could call it one piecewise function. But we can't. That's why I labeled it as 4 different functions, because it depends on the plan you choose. It's not automatic. It's not as if the phone company will automatically switch you over to the proper plan depending on how many texts you send out. You know what I'm saying?
Right.
So this notation you have here, it's actually not incorrect, but it might be incorrect if we put it all as one function with 4 different pieces. I'm not sure that that would be correct to do.
Okay.
Okay, because you do have to pick. In other words, it's not automatically, if you send 401 texts, it's not automatically going to go to this function C.
Right.
In fact, it would still use this function B. If you signed up for plan, 400 messages, and X is actually 401, you're still with this function. You don't automatically go to the function in part C. So you can't really say that. In other words, you can't say for part B. The answer is for part B, it's 499 plus 0.15x, and x is not restricted.
Right.
In other words, you don't want this restriction part here, the domain restriction that you've given it. It's just 499 plus 0.15x, no matter what x is. Or, excuse me, plus x minus 400 times 0.15. It's the f of x in my drawing over here. That's what it is. And I can't say that x is between 0 and 400. It isn't. X could be 1,000 there. X could be 10,000. If I've chosen that plan, that wouldn't be the best plan for me to choose, but x is still not restricted there, other than maybe x has to be greater than 0. But that's the only restriction.
Okay.
Okay? I know that it probably makes a lot of sense what you've written here, and it normally would, but this is kind of a peculiar problem. It's not a real true piecewise function. It is just 4 separate functions depending on which plan you choose.
Okay.
Okay, so for number 3, that's straightforward enough, especially if you have your 4 functions. So with no plan at all, she's going to pay what?
$180.
Well, what? 1,200 times 0.15, right?
Yeah, I had that one right. I don't think
Right, which is 180, okay. And then on the 400 text plan, she would pay $499 plus 800 times 0.15. What is that?
124.99.
Okay, so that's the answer for B. On the 1,000 text plan, what would she pay?
$39.99.
And the unlimited text plan?
$14.99.
Right, so that's way the cheapest for her.
Right.
Just to pay the unlimited one. All right, let me go to the back of this page. Interesting why that came into my spam. Google's pretty good about spam. They rarely are wrong.
Yeah.
I'd say 1 in 1,000 gets put into my spam folder when it shouldn't.
I like the Gmail website versus going and logging into the Gmail on whatever email app you have.
Yeah, I use Google Chrome. So,
yeah, it's really
and
cool.
I like Google Chrome, and I love Gmail. To me, I haven't ever found a different email program that's better than Google Chrome, including their spam filter, which is normally terrific. All right, so number 4 says, if you're going to send 90 texts per month, which plan should I purchase? Convince me with math. So what are we going to have to do here?
at worst, plug 90 into each of the equations.
All four of them. In other words, this is kind of like question 3. We proved that if she had 1,200 texts per month, she was much better off with the unlimited plan. But with 90 texts per month, which two do you have to compare? You only have to compare 2. You really don't have to compare all 4.
Just the no plan and the unlimited.
Well, probably the
Correct.
no plan and the 400 text plan.
With the 400 text plan, wouldn't the answer come out as negative?
No, you bring up a good point. Maybe that function needs to be, wow, okay, you're right. Well, that function we came up with wasn't quite right. Let me think for a second how we avoid a negative number there. I wonder if we need a logistic function.
Can we make it a piecewise and make the limit just positive numbers? Would that do anything?
I'm trying to think how we can do this. In other words, we want the second part of that function to be 0.
Right.
So we could say that only for x greater than 400, in other words, I'm trying to how we can do this. We could say that we could put a domain here and say only for x greater than or equal to 400. And if x is less than 400, then it's not this function. In other words, we do kind of maybe need a piecewise function here. Now, let's see if I can set this up as a piecewise function. Hold on a minute. And let me put the first function here. In other words, the first function, which I'll call e of x equals 0.15 times x. X has to be greater than or equal to 0. Well, let's call that d. I don't like using the variable e. D of x. So that one makes perfect sense, right? If we choose no plan at all, we're just going to pay 15 cents times however many minutes we use. And this is kind of an interesting problem. In other words, I still think it's a bit of a mistake to do this. It depends on the plan you use. Well, we can certainly answer the question. I'm not convinced I have it. In other words, I'm not totally convinced that I did 2 correctly now. Perhaps you can do, in other words, this is the function for 2, but you do have to restrict the domain. In other words, that is only if x is greater than 400. Question is, what if you choose the $4.99 plan and you only use 100 minutes? then you got to make sure the cost comes out to be $4.99, and our function doesn't do that.
Right.
So how can we write that function so this part of it turns out to be 0 if x is less than 400? How would we do that? I guess we don't do that. We just restrict the domain. In other words, with 90 texts per month, what is going to be the cheapest plan with 90 texts per month? Convince me with math.
It is the no plan.
Yeah, because that, or
It's either that or the unlimited.
hold on. The no plan would be $13.50.
Yeah.
How about the plan that's $4.99? In other words, the 400 texts per month. Remember that it's only, you only get charged 15 cents for all of the texts that are greater than 400. So with 90 texts, if you were on this plan right here, you would only pay $4.99.
Okay.
And in fact, you would actually be better off on either of these two plans here, because
Right.
this cost ends up being $13.50. So the only plan that would be more expensive would be the unlimited, which would be $14.99. But G would be $9.99. That would be cheaper. And the first one, the 400 texts, is $4.99. That's cheap.
Okay.
So that's the cheapest option. And the math isn't that hard to, in other words, convince me with math. Well, that's pretty easy to do. However, I'm still a little questioning whether we have the exact answer on number 2. I don't suppose you have answers on these?
No, I don't. I wish I did.
Well, I don't really need it. It's more of a formality, I believe, as to how to express the function. We've expressed the function properly as long as you restrict the domain on x with each one.
Right.
So number 5. Okay. So how many texts would you have to send before it makes sense to go with the 400 text plan? Clearly 90 was way more.
Right.
So how would you figure it out? What if we make sure that this cost is less than $4.99? In other words, that's what we need to solve. What does x have to be less than? Use your calculator.
33.3.
So if you had 33 texts, it would be cheaper to have no plan. And if you had 34 texts, it would be cheaper to go with the 400 text plan, right?
Right.
Okay. Now let's keep doing that analysis. Let's see, what's the next one we have to decide is when does it make sense to go to the 1,000 text plan? If you send exactly 400 texts, which plan is the cheapest?
The 400 text plan.
Right, just $4.99 is all it would cost you. Okay, so what we have to decide is when does it make sense to go to the $9.99 plan? Well, when this amount, let me circle it by itself, when the amount that I have circled there, when x minus 400 times 0.15 is greater than what?
X minus 1,000 times 0.15.
How about $5? Let me think about that for a second. Because $5 is the difference between the costs of the plans. In other words, if I send,
Oh, okay.
let's say I send 500 texts. Well, it's got to be less than or equal to $5, not greater than. That's the equation we have to solve right there.
Okay.
Let's see if we can come up with that exact number. I don't know why I can't divide before distributing. So I get x minus 400 is less than or equal to 5 divided by 0.15.
33.
Which means x has to be less than or equal to 433.33. If x is less than 433.33 and greater than 400, then the best plan is your 400-minute plan. If x is 434, well then you would pay $4.99 plus 34 times 0.15, and that number is greater than $5.
Okay.
In other words, what is that number? That number is 34 times 0.15. That's $5.10. Meaning that if you sent 434 texts, you would pay under the 400 text plan, you would pay $4.99 plus $5.10, which is greater than $9.99. In other words, under the 1,000 text plan, you're only going to pay $9.99 for X between 400 and 1,000. You're just going to pay $9.99. Yeah, these functions aren't right. I'm trying to figure out how I can make these functions so that when x is outside the domain that this ends up being 0, not a negative number. In other words, we want this to be such that if x were equal to 300, this whole thing goes to 0. How can we do that? How can we structure that function so that that's the case? Because right now that ends up being a negative number, and we don't want a negative number there. We want 0. There's no additional cost. I guess this is what does it. Yeah, here's what we want. We want the cost is $4.99 with x being greater than 0 and less than 400. And the cost is $4.99 plus 4 or x minus 400 times 0.15 when x is greater than or equal to 400 and less than or equal to 1,000. And it's $9.99 when x is less than or equal to 1,000, and it's $9.99 plus x minus 1,000 times 0.15 whenever x is greater than or equal to 1,000. That's how we're going to do this. We're just going to break it up into multiple piecewise functions. And this is correct. In other words, and then it's $14.99 whenever x is greater than that's for all x. That's for x greater than 0 and x is less than x greater than 0. If that's the plan we've chosen, then it doesn't matter how many texts we send.
Okay.
I think that handles our difficulty. And then at the very top, it's just 0.15 times x whenever x is greater than 0. So we don't really have a piecewise function. If you look at those domains, they're not mutually exclusive.
Right.
But it depends on the plan. In other words, this is no plan. 0.15 times x, x just greater than 0. This is with the 400-minute plan, but it is actually a piecewise function. In other words, if x is between 0 and 400, you pay $4.99. If x is between 400 and 1,000, you pay $4.99 plus x minus 400 times 0.15. So that's the way this is going to work. In other words, this is the 1,000 plan, and this is the unlimited. So this is actually going to be the answer for number 2.
Okay.
Where they asked us to come up with a function for each plan. Well, 2 of these plans have a piecewise function, and 2 are for any x greater than 0.
Okay.
All right. And this is a totally new problem here, right? Yeah. So the last problem here is similar to the other, only the other we had four options, and this one we only have two.
Okay.
So let's see, well, do we actually need to write the piecewise functions? Yeah, it looks like we do. In other words, part C and part D require us to write a piecewise function. For part A, you know, it actually makes more sense to graph or to do C and D first.
Mm-hmm.
I don't know why they didn't ask. In other words, A should be C and B should be D, and then A and B should be C and D. Because you kind of have to figure out the function. Maybe they're, I guess you don't really have to figure out the function to answer A. You just have to plug it into both options. Now let's do it in the order they want. All right. So if you're driving 300 miles on plan 1, what's the cost?
$50.
Okay. On plan 2, what's the cost?
$65.
So it's 30 plus what?
Plus 0.35 times 100.
Correct. In other words, the number of miles minus 200, right?
Right.
Okay. So the cheaper cost then is plan A.
Right.
Okay. How about if you're going for 800? Hold on a second. We didn't quite do this right. On the course of a 6-day trip, it's $50 per day.
Oh.
So
Gotcha.
let's go back and look at plan A again.
So it's 300 for plan A.
Plan B would be 30 times 6
215.
plus 100 times 0.35. Cheaper. Plan B. And that is, even if you're only driving 300 miles over the course of the 6-day trip, plan B is cheaper. So what do you think is going to be cheaper for question B? Without doing any math.
I think A.
Yeah, maybe, although they are in conflict with one another. In other words, A is more expensive per day but gives you more miles for free. Whereas B is cheaper per day but gives you less miles for free. So we really have to test them both out. So what's the cost for the 800-mile trip? $300 plus what under plan A?
The total is $405, but it's 0.35 times 300.
It's actually only 0.25 for each additional mile under plan A. See that?
Yeah.
In other words, so if we're going to drive 800 miles, we're going to have $300 plus 300 miles times 0.25, which is $75. So that cost is $375. Under plan B, we got 30 times 6, 180, plus, and now we have 600 extra miles at 35 cents per mile.
390.
What's that total?
$390.
Ah, so plan A. You were right. But it wasn't that obvious, and they're not that different. Yeah, the difference in these two plans is fairly dramatic. Okay, so now we get to part C. Write a piecewise function for the cost of plan A. For a 6-day trip with X number of miles. So what's my cost? Cost as a, we'll even label it C. Cost as a function of X is going to be what? As a piecewise.
$50 times 6. Plus
Put your domain on there.
X minus 500.
No? In other words, it's 50 plus 6 as long as X is greater than 0 and less than 500.
Oh, okay.
Right?
Right.
In other words, if you go 499 miles, you get 500 miles for free. There's no additional charge. The cost is equal to 300 less 0.25 times X minus 500 if what? If the domain in other words, what should my domain read over here?
X has to be at least 500.
Greater than or equal to 500. And in fact, if that's the plan we're choosing, that's our cost. There's only two parts to that piecewise function. If X is in this range, it's $300. If X is in this range, it's $300 plus 25 cents times every mile in excess of 500, which is X minus 500. Yeah, this is what we figured out how to do on the previous problem also.
Right.
Now let's write the piecewise function for plan B. This is plan A, and we'll call it plan A. What's B of X?
$30 times 6.
180. If X is what?
Greater than 0 and less than 200.
And you can use less than or equal because it's going to come out exactly the same.
Right.
In other words, 200 will be no additional cost. So if you travel exactly 200 miles, you'll pay 180 bucks. But it's equal to 180 plus what if X is greater than 200?
180 plus 0.35 times the quantity of X minus 200.
There you go. There it is.
Okay.
And now I can kind of see why they did it in the order they did it. In other words,
Yeah.
in order to answer A and B, you kind of had to use this formula.
Right.
And so by answering A and B, it helps you come up with C and D. make a graph of both functions on the same set of axes. Okay? I'll do the first one in blue. That'll be a of x. How should I draw this graph? Let's start by putting our key points. There's 200. There's 500. And this is the x. And this is the, we'll call the blue a of x. So what's my graph look like up to 500? Where on the vertical axis should I draw my line?
At 50?
At 300.
Or, yeah, sorry, 300.
Okay, so we'll put it 300 right there. In other words, it's a horizontal line to that point right there, right?
Right.
And any time that x is greater than 500, then it's that. Well, what kind of slope is that?
Is that another
horizontal
line?
Horizontal line. I'm going to have a line that's got slope. What's the slope going to be greater than 500?
0.25.
Yes. Which means I got to go up 1 and over 4. Okay? So it's going to be relatively flat. We'll call that a slope of 0.25. Now let's draw the second function, b of x. Well, its appropriate point is 180, and it's a horizontal line, excuse me, the horizontal line to there. And then anything in excess of 200, what's the slope of that going to be?
0.35.
Which is a little steeper than that. So it's not parallel to that. I'm going to draw it like that. Okay, and this slope equals 0.35. And that should do it in terms of answering their question. Let's make a graph of both functions on the same set of axes. After how many miles does plan 1 become cheaper? Well, if I look at my graph, this point right here, is it not?
Yes.
So how do I figure out what that point is?
Is there a way to do it algebraically?
Yeah. That's the set one function equal to another. Now, I can see that that point comes between miles of 200 and 500. So I'm going to use that. Hold on a minute here. No, I got, in other words, I know my cost of plan A is 300 bucks. up to 500 miles. So we
Right.
have to figure out where the cost of B is equal to 300 bucks.
Okay.
Well, it's clearly when X is over 200, right?
Right.
So we'll use this function, set it equal. In other words, this part right here that I just circled in red,
Mm-hmm.
that has to equal 120, right?
Right.
The moment that equals 120, then my cost is the same between the two plans. So I can do it this way. I can either say 0.35 times x minus 200 has to be greater than or equal to 120, or I could say 180 plus this has to be greater than or equal to 300. They're both the same. You see that?
Yeah.
In other words, I've already done the first step of the algebra here by making, it should have been this, 180 plus that has to be greater than or equal to 300. Subtract
Okay.
180 from both sides, and I get greater than or equal to 120. Best way to solve this? What's the first step?
Divide by 0.35.
Yeah, notice that there are two different ways to solve it. I could distribute the 0.35,
Mm-hmm.
but that actually makes for harder math because
Right.
I got a number 0.35 times 200 that I'm going to have to take to the other side. Let's just divide both sides by 0.35 right away. What do I get?
342.857.
If I add the 200, oh dear, that's problematic. Really problematic. Because when X is greater than 500, the cost of plan A is no longer 300 bucks. It's 300 plus. So re-examine this. We want to know where they're the same. Well, what do we have? We have 300 plus 0.25 times X minus 500. Where is that going to be equal to 180 plus 0.35 times x minus 200? That's what we have to solve, is that equation there. In other words, this is, whenever x is greater than 500, that's going to be the cost. And we just figured out that x was going to be in the neighborhood of 542. So we have to use this part of the piecewise function, not the first part. And if I do this math, what do I get? 300 plus 0.25x minus 125 equals 180 plus 0.35x minus 70. Now, if I move my variables to the right, I get 0.10x. Move all my numbers to the left. Got 110 over there. I got 175 on the left. That's 285. I X is equal to 2,850 miles? That's the break even? According to my graph, that's impossible.
Right.
Because the slope on plan B is never going to intersect that slope on plan A to the right of some number. In other words, I could believe that I drew it incorrectly. In other words, maybe plan B looks more like this. So it crosses at a point where X is greater than 500. An interesting problem. After how many miles does plan 1 become cheaper? We can kind of do trial and error.
Right.
500 miles, plan 1 is 300 bucks, plan 2 was more than 300, right?
Right.
So plan 1 is cheaper somewhere between 200 and 500 miles. So all we have to do is figure out where the second function is equal to 300 bucks. Oh, we did that. The second function is 180. Yeah, we did that. Plus 3.5 times X minus 200. That has to be equal to 300. We did this and it came out to be greater than 500 miles. Oh, I guess that makes sense actually. If you went exactly 500 miles, plan 1 is cheaper. We figured that out, right?
Mm-hmm.
What if you went 600 miles? Plan 1 is way cheaper. If you went 1,000 miles, plan 1 is cheaper. So there has to be some number less than 500 where plan 1 is more expensive. For example, 200 miles, plan 1 is a lot more expensive, right? Plan 1 would be 300 bucks, plan 2 would be 180. So it's some number between 200 and 500 where they're the same. For example, 400 miles, just to finish this up before I let you go here, 400 miles would be 180 plus 0.35 times 400 minus 200. Well, that's only going to be 250 bucks. That's still cheaper. How did we end up with, I think with 500 miles, plan B is cheaper. It is. By just a hair. Our answer was correct. 542, the original answer we came up with.
Okay.
Our problem is that when we did the math based on 500 miles, we did it wrong. 500 miles would cost 180 for plan B plus 300 times 0.35, well, that's only $105. So that total is $295. That's cheaper than Plan 1, which would be
Okay.
500. So some number greater than 500 is our answer, and the first time we did this, we got 542, I believe. I think I erased it all because I didn't think that could be the answer because we had made a mistake the first time through. That's because our two considerations were 300 and 800. And somewhere right greater than 500, the two plans are the same. And we did come up with a number, 542. That's got to be that answer.
Okay.
All right.
Mr. Cohen, I have two more questions. Could you possibly help?
Sure.
Great, thank you. They're out of the textbook and there's small pictures, so I just sent you the pictures. I'm really sorry.
That's all right.
So it's and on the pictures it's numbers 8 and 9. Number 8, the whole thing's on one picture, and then 9, the question is.
Did you send it to my email?
Oh, I'm sorry. I just sent it to your phone number.
Yeah, that doesn't help. I can't bring that up on my computer.
Sorry.
You send it to that email again.
Yeah.
I could probably take whatever you sent to my phone and forward it to my email, but it's actually going to be quicker for you to do that, I think.
Yeah, for sure.
Just resend it. Just holler when it says sent.
Okay. Okay, there's the first one.
Okay.
I'm sorry, I have to send it in 3 separate parts.
That's fine. I got the first one. Let me open it up.
All 3 are sent.
All right. Oh, I love this. This is a calculus problem. Are we doing 8?
Yes, and 9. The picture for 9 and then the actual questions are on the other pictures.
Okay. The blue semicircle that you see there is expressed by that function right there, y equals square root of 4 minus x squared.
Okay.
Okay? If we're trying to figure out the area of that rectangle that can be inscribed in the semicircle, express the area of the rectangle as a function of x. Well, what's the base of that rectangle? Let me move it over just, yeah, you can see it. This is not the easiest thing to understand. But it's a critical part of calculus. What's this measurement right here, where my check mark is? What's the x-coordinate of that? X.
2, 0 or 2, 0?
It's x.
Oh.
That's why it's hard to understand, because it's not a number, it's x. What's the y-coordinate?
Just y?
Correct, but we know that y, since it's on that semicircle, we know what y is. Y is the square root of 4 minus x squared. So the coordinate that I've written there is actually x, comma, square root of 4 minus x squared. That is what y is equal to. Now let's look at that rectangle. What's the base of the rectangle equal to? Area equals base times height. Well, in terms of x, what's the base equal to? Two x. You see why it's 2x?
Oh, right,
In
yeah.
other words, x is the distance from there to there. Well, we've also got the other distance, an equal amount in the other direction, so our base is 2x. And our height is y, which is the square root of 4 minus x squared. There's our area function as a function of x.
Could we also, in that function, could we also put y as just x? Because on the picture it says that the height is congruent to half of the base.
Where does it say the height is?
The dashes on the lines, on the segments.
Oh, I don't, no, those don't mean anything. That dash is 1. That dash is minus 1, and that dash is plus 1. So they're really immaterial, those dashes.
Oh, okay.
Those aren't
Gotcha.
hash marks as in geometry.
Right.
That's not telling you that that's equal to that, even though they are. But those don't have anything to do with the area. The area, the point, that point is x comma y, which means it's x comma square root of 4 minus x squared. Okay, so we've got our area as a function of x, exactly right. It's 2x times the height, which is this. Now express the perimeter of the rectangle as a function of x. Perimeter of the rectangle is what?
4x plus 2 times the quantity of the square root of 4 minus x squared.
Perfect. C, graph a of x for what value of x is a the largest? Well, I assume that they're going to let you use your calculator here
Yeah.
because we don't know how to graph that otherwise. Okay? In other words, you have to, in your calculator, put in the a of x function, and then from your calculator, find where on that function a is the largest, because this is the calculus question. The calculus question is, what is the area of the maximum rectangle that I can fit into that semicircle? Notice that I can do it a lot of ways. If you look at my drawing here, I don't have to do it that way. I can fit that rectangle in there. Well, which one is bigger? Is the green rectangle bigger or the black one? We don't know.
Okay.
And that's where calculus helps a lot. Calculus lets you find the maximum place of that function by taking its derivative, letting it equal 0. To do it without calculus, you would graph that. You would end up with a graph that looked like, that's a quadratic. That graph's going to look something like that. Notice how I know that's a quadratic. If I took just the square root of x squared, it would be an x times x So the result of that is going to be a quadratic.
Okay.
If I was able to actually multiply those two together. But the function should look like a parabola. And this is the point they want, that peak. That's the place where the area is the maximum. And same for P. P is a different function, but you can still put that into your graphing calculator and find out where the peak of that thing is.
Right.
Now, there could be some domain considerations here. In other words, you know, it might be worth graphing just one of these on my Wolfram Alpha so that we can see what's going on here. Hold on. What's the area function again? Equal
A of x equals 2x times the square root of 4x squared.
4 minus x squared. So it'd be
Yes.
4 minus x squared, all raised to the 0.5 power. Correct, right?
Yes.
The blue is the real part, the orange is the imaginary part. Oh, and this time finally it plotted it, okay?
Okay.
Notice where my crosshairs are?
Yeah.
That's the maximum of the area function.
Okay.
Now, we are limited to being between 0 and 2 on the x-axis. In other words, when x is greater than 2, we're taking the square root of a negative number, so x can't be greater than 2. And x can't be less than negative 2. Hence, that's why they give you the orange here. That's the imaginary solution.
Okay.
In terms of our actual domain, x has to be between minus 2 and 2, and you can see that from the picture. Notice in their picture, x has to be between minus 2 and 2, otherwise it would be outside the circle.
Right.
So regardless of what this graph were to look like, in other words, even if it wasn't imaginary only, let's say that was blue there, well, we would still only want the peak in our practical domain, and our practical domain is minus 2 to 2.
Okay.
Okay? But even still, that if you graph this thing on your calculator and you try to find the maximum, that's where you'd find. And it's some number greater than 1 and less than 2, we can see.
Okay.
In fact, let's see if they give us the answer. The global maximum is square root of 2 and minus square root of 2 is the minimum. So x equals square root of 2 is going to be that maximum. And then we could do the same thing for part D. In other words, whatever our perimeter function was, which was 4x plus 2 times this quantity,
Right.
graph that and find out what value of x gives you the largest perimeter. Again, x would have to be between minus 2 and 2. How is 9 different than 8? Or I don't have the picture on 9.
Yeah, I'm sorry. I accidentally missed it in the picture, so I sent another one.
Okay, hold on a minute.
But it's a full circle, but it has the same equation as the semicircle.
Right.
When you rearrange it, it says x squared plus y squared equals 4. I'm sorry, that's still not those are the questions for 9, but that's not the one with the picture on it.
Okay, maybe I needed to pull up this one here. Yeah, I see it now. Okay, so the questions for 9 are what? On the next page?
Yeah, they're the same as they're the same as the question for 8,
8?
which you're right. That picture works fine. It's the same questions.
Okay. So the only difference is the base of the rectangle is still 2x. What's the height of it?
2x.
2y. In other words, if it's y from here to here,
Right. Okay.
the total height is 2y. And we know y is still, notice that if we solve this equation of the circle here, you get y equals plus or minus the square root of 4 minus x squared.
Okay.
Okay? But looking at that rectangle, the base is 2x and the height is 2y. And we know what y is.
Right.
And we can use the plus square root of 4 minus x squared. The perimeter, again, is going to be two bases plus 2 heights. So the base is 2x, so the perimeter is still going to be 4x plus 4y now. So that's really the only difference between problem 8 and 9.
Okay.
Is in 8, the base of the rectangle is 2x and the height is 1y. And in 9, the base of the rectangle is 2x, but the height is 2y. And use what they gave you for y in 8. Y is still the square root of 4 minus x squared.
Okay.
It's just when you have a full circle like this, if I solve for y, I get plus or minus. Well, the plus is the upper half of the circle. The minus is the lower half, the lower semicircle.
Right.
Because a circle is not a function. It does not pass the vertical line test. In this case, the circle is a composite of 2 different functions. The one function being the upper half, that semicircle, that's the plus square root of 4 minus x squared. The minus square root of 4 minus x squared is the lower one. But you can ignore that when you're coming up with your answer because we can see that the base is 2 x's and the height is 2 y's. So we can use just the positive to figure out that answer.
Okay.
Does that take care of you?
That does, yes.
All right. I hope that works for you. And let's see, you're scheduled for tomorrow night, right?
Yes, every night this week, I think.
Okay. I will talk to you.
Great. Thank you very much for the short notice and
No problem.
staying longer. I really, really appreciate it.
No problem at all. William, talk to you tomorrow night.
Thank you. You too.